So hi, thank you again for the invitation today, Marianne, and thank you to everyone attending. I'm going to be presenting some work that I did with colleagues at the University of Hawaii at Manoa, as well as the University of Wisconsin. And as Marianne mentioned, my background is actually not in health per se. It's actually, I'm a marine chemist, and I actually do a lot with water quality. So this has been a really interesting project to be a part of. So today I'm going to be talking about the results of our recent paper that was published in Nature Climate Change, entitled "Over Half of Known Human Pathogenic Diseases Can Be Aggravated by Climate Change." And I'm honored to present this on behalf of my co-authors. Numerous studies have documented the impacts of climate change that it is having on disease on local and regional scales, but no previous work has conducted such a comprehensive review to fully understand the threat that humanity is facing from climate-aggravated disease. And this is what we attempted to do in our study. First, I'm going to give a bit of a background on climate change and how it's currently impacting our lives today. I assume that many in this group are well acquainted with these impacts, but it's always good to cover the basics. So just some basic information on the greenhouse effect. This is shown by the figure on the top left of the slide. Earth is warmed by the sun, and then much of that solar radiation is then absorbed by Earth's surface. This is then radiated from Earth's surface as infrared energy, where some is then absorbed by the greenhouse gas molecules that are in the atmosphere. And what's important about this is that greenhouse gases mediate the balance between solar radiation coming from the sun and outgoing infrared radiation from reflection off surfaces. Additionally, once these greenhouse gases are in the atmosphere, their impacts are long-lasting. And so, for instance, carbon dioxide will remain in the atmosphere for 300 to 1,000 years and will likely lead to lasting changes, some of which we're already experiencing now. And the plots on the right side of the slide show carbon dioxide in parts per million and that are in the atmosphere. This top plot shows the concentrations since 1960, when carbon dioxide levels really started to accelerate following World War II. The bottom plot shows carbon dioxide concentrations over time from about 40,000 years ago to present. And this graph is a few years old, but the orange arrow shows where we are now. And you can see it's off the chart. We're actually off of the scale now. Humans have never before lived in a world consistently beyond 400 parts per million carbon dioxide, and that's where we are today. So the Intercontinental Panel on Climate Change, or IPCC, outlines 5 different emission scenarios for the next 100 years. And in particular, I want to point your attention to the RCP 2.6 and 4.5 pathways where human-induced warming by 2100 remains under 2 and 2.7 degrees respectively. For a long time, this 2-degree benchmark was seen as a feasible goal, but also one with significant consequences. Now, even several years later, the best estimate for where we're headed is 2.7 degrees of warming, assuming that the Paris Agreement holds. Both of these scenarios require substantial mitigation of greenhouse gas emissions. And it is also worth noting that many climate scientists believe that 4 to 5 degrees of warming by 2100 is likely. And the consequences of even 2 degrees of warming are severe. When most people think of climate change, they think of the weather, but climate change has widespread influence on pretty much every aspect of life as we know it. And so here, once again, I've pulled a figure from the IPCC report that shows the degree to which climate change is already contributing to physical, biological, and human systems on Earth. This map represents the current situation, but one should expect that this story will be significantly worse should we continue to use fossil fuels. And these impacts are already being observed to be dramatically worse in less wealthier nations and in equatorial and polar regions. So here's a figure from Mora et al. In 2014 showing projected impact of climatic hazards under the RCP 8.5 scenario. And briefly, red indicates an increase in a hazard and blue indicates a decrease. And again, I just want to point out that the equatorial and polar regions are especially impacted. So in our work, we considered 10 different climatic hazards. As I mentioned before, greenhouse gases mediate the balance between solar radiation coming in from the sun and outgoing infrared radiation from reflection off of surfaces. And so this figure shows a simplified view of how these various climatic hazards that we looked at in the paper can influence one another. So excess greenhouse gases in the atmosphere cause warming, and this warming allows the air to hold more water, allowing for more evaporation to happen at a faster rate. This process then leads to excess drought in dry places, and then heat waves can occur when the heat transfer for water evaporation no longer occurs. This also leads to increased opportunity for wildfires to occur. This accelerated water evaporation for warming can also lead to increased precipitation, which if it occurs over a short period of time, can lead to flooding. And then warming enhanced evaporation of ocean water enhances the strength of storms and can also lead to storm surges impacting sea level and thus also flooding. Ocean biogeochemical and physical changes such as warming, ocean acidification, changes in currents, these all fall under ocean climate change. And then finally, we included land cover in the paper because of its impact on greenhouse gas emissions and its demonstrated effect with disease transmission. So in our research, we carried out 3 complementary literature searches following the PRISMA guidelines for reviews. For our search, we specifically looked at empirical case examples where a specific climatic hazard influenced a specific disease in a specific place and time. So that means that our results should be considered conservative. We used Google Scholar to find our papers, and for the first search, we searched the word disease along with each of the 10 climatic hazards. In the second search, we looked for each of the 10 climatic hazards and the diseases listed in the Gideon and American CDC databases. This includes 375 diseases in all. For the final search, we wanted to confirm that we didn't miss any diseases, and so that we searched each disease and pathogen name synonyms. We conducted a comprehensive review of the available literature, but it should be worth noting that there may be a publication bias towards examples with negative consequences or for diseases that are less rare. And so, for instance, the neglected tropical diseases may be less represented in the literature. We took extra measures in our search, such as documenting all examples of climatic hazards leading to not only aggravating disease, but also to cases where there was no effect or that a disease was diminished, to make sure that we accurately represented the available literature. And it is also worth noting that our study demonstrates the linkage between climate change and disease, but we did not specifically evaluate the impact that climatic hazards have on frequency, severity, or prevalence of specific diseases. All right, so what did we find? Here I show a simplified version of our online interactive database, which you can access following the link on the slide. It's right here on the bottom. I'll pop that link up again. And this figure shows the numerous pathways that these greenhouse gas-driven climatic hazards via a variety of transmission types can aggravate human disease. Line thickness is proportional to the number of diseases impacted, and the numbers indicate the number of diseases. So, and each column is in order of decreasing number of impacted diseases. So just reading off of the top, we see that warming was associated with aggravating the greatest number of diseases. That is 160 different diseases. Vector-borne transmission was associated with the most common transmission pathway, responsible for aggravating 103 diseases, and that viral diseases were the most aggravated, 76 diseases. Breaking this down a bit further, we found that 58%, that is 218 out of 375 diseases impacting humans, are aggravated by climate change today, as is represented in the literature. Of the documented cases of diseases influenced by climate change, we found that 78% were exclusively aggravated by climate change, with only 3% exclusively diminished. And in addition, we found over 1,000 pathways for climatic hazard-driven disease transmission. Again, vector-borne transmission aggravated the greatest number of diseases, and warming, precipitation, and flooding led to the increase in the most diseases. And moreover, we were able to put all of the case examples we found, they all fell under 4 different mechanisms for climate pathogen interaction. These were climate-related hazards bringing pathogens closer to people. So, for example, warming and precipitation changes were led to increased habitat suitability for vectors at higher latitudes, elevations, as well as temporally, such as vectors being able to survive over winter months. This has also been associated with the range expansion of vectors such as mosquitoes, ticks, fleas, snails, birds, mammals, pretty much you name it, and has led to outbreaks of mosquito-borne diseases such as dengue, chikungunya, and Lyme disease, for example. The second mechanism we found was climatic hazards bringing people closer to pathogens, where people can undergo a forced displacement due to a hazard occurring. So for instance, storms and floods have led to increased cases of waterborne diseases such as cholera and leptospirosis. Our third mechanism that we found was climatic hazards enhancing pathogens. And this includes, for example, improved environmental stability for vectors. For instance, storms, heavy rainfall, and flooding have led to increases in stagnant water and thus have been associated with leading to increased cases of mosquito-borne diseases. And then the fourth mechanism we found was that climatic hazards can reduce human capacity to cope with pathogens. For instance, through forced exposure to pathogens such as unsafe conditions, damaged infrastructure, reduced access to medical care, and also as well as the impacts that stress can have on the human immune system from living through a hazard. And so, for instance, we found that drought led to reduced sanitation and was implicated in increases in a large number of diseases, for instance, dysentery and E. coli. So I just want to flash up the web tool again. This is a fully interactive database where you can find all of our case examples online. All of the papers that we read are linked in PDF form, and it is also searchable. So if you're interested in a specific location, for instance, if you just go up to the entries link, you can search the database for whatever you're seeking. And yeah, so just leave with a couple take-home messages. The first is we found that 58% of diseases impacting humans are aggravated by climate change, with over 1,000 pathways for climate hazard pathogen transmission. Secondly, that atmospheric warming, rainfall, and flooding were associated with enhancing the most diseases. And finally, the reduction of greenhouse gases is absolutely necessary given the magnitude of diseases impacted. Disease mitigation strategies really benefit wealthier nations, and so really are not a solution, or not the solution, not the primary solution to this problem. Thank you.